Bismillahirrahmanirrahim. Dear students, last time we finished the chapter number 17, alkyl halides, and according to your reduced syllabus we received from the Federal Board Islamabad, we completed the chemical reactions of Grignard's reagent with the aldehyde, ketones, esters and carbon dioxide gas. Now, today we start the chapter number 18, grade 12. Alcohols, phenols and ethers according to the revised syllabus. This is lecture number 51. So, first one, alcohols. Alcohols are alkyl group and OH group. These are called alcohols. There are three kinds of alcohols. Primary alcohols. Primary alcohols means this carbon has a CH2 attached with the OH group. CH2 attached with the OH group, and this carbon will only connect with one carbon atom. This is called primary alcohol, 1-propanol or N-propanol. Then this is a secondary alcohol, and this carbon which is the center, two more carbon attached with it, and there are CH and OH group attached. This is called 2-propanol secondary alcohol. Third one is called tertiary alcohol. In the center there the carbon, only one carbon is there, no hydrogen attached. All three alkyl groups carbon atoms are surrounding it, and there the OH group. So we call it tertiary alcohols and tertiary butanols. So these are the types of the alcohols: primary, secondary and tertiary alcohols. Now the second topic is nomenclature. Nomenclature of the alcohols. Nomenclature of the alcohols. So, if the alcohol is present, there are two kinds of the alcohols: monohydric alcohols, one hydroxyl group, and the polyhydric alcohols. There are more than two hydroxyl groups are there. They are called polyhydric alcohols. So according to IUPAC system, the longest chain of carbon atom containing the hydroxyl group. That's why you have to say this longest chain. So suppose we have here like this one. So this is the OH group attached here. So starting from here, 1, 2, 3 and 4. Longest chain is 4, and this is a branch here. So this is a 2 methyl 1 butanol. 2 methyl 1 butanol. So this OH group attached with CH2. This is a primary alcohol. There is a secondary carbon. But this carbon is not directly attached with the functional group. So this CH2 attached OH is a primary alcohol. So you have other also points. Ending E of the parent hydrocarbons is replaced by the O. Alkane changes into alcohol. Position of the hydroxyl group is indicated by placing the number of carbon atoms which is OH attached before the name of alcohol. Carbon chain bearing OH group is numbered beginning that end. From this end we have to give the numbers. From this end we have to give the numbers 1, 2, 3. 1 through this name is 1, 2, 3, or 1, 2, 3, or 1, 2, like this one. So you have 1, 2 and 3. So 2 methyl and there is the functional group on the second carbon, 2-propanol. So these are the rules. The presence of more than one hydroxyl group, that's why polyhydric alcohols. This is the ethylene glycol. Ethylene glycol 1 and 2. On the carbon number 1 there is alcohol, and carbon number 2 there is alcohol. It's called 1,2 butane diol. 1,2-butyl-diol or ethylene glycol. If like this, this is a glycerol, glycerine or glycerol 1, 2 and 3. So 1, 2, 3 propane triol. So this is a case in which the three hydroxyl group are going to be attached with this one. So 1, 2 ethane diol or 1, 2, 3 propane triol, or we call glycerol. These are the common names. So dear students, if there is a in between there is a alkene functional group like this one. This is the alcohol. So this is in between here, and the fuse must start from this side. 1, 2, 3, 4, because the hydroxyl group OH group will attach with this carbon number 1 and this middle. So there is a carbon 2 and the carbon 3. There is a ene starting from here. The position of number 1 is 2 ene, 2 ene and 1 butanol. 2 ene, 1 butanol. This is the nomenclature of another type of alcohol. Then after nomenclature, physical properties. Now alcohols are highly polar in nature. Alcohols are highly polar in nature. They have also hydrogen bonding due to presence of OH group, oxygen and hydrogen, but weaker than the water. So both are highly miscible with each other. This is the alkyl group, and like this one. So this is the one partial negative and this is the partial positive. So this partial positive must be here with another type of the alcohol like this one. So this is the hydrogen bonding between the hydrogen of one alcohol and oxygen of the other alcohol group here. So this is the alcohol group, partial negative charge, partial positive charge. This partial positive charge on the hydrogen. So this is the hydrogen bonding between the alcohol, and hydrogen bonding also present in water like this. Partial positive charge, highly electron deficient hydrogen, highly electronegative oxygen to form a hydrogen bond with the water. And if these two compounds, alcohol and water, dissolve with each other, so their hydrogen bonding is broken down and they form a new hydrogen bonding with the water and also alcohol. So alcohol and water, they form hydrogen bonding like this one. This is the water, lone pair here, partial negative, partial positive. So this is the oxygen of the water and this is the hydrogen of the alcohol like this. So they form the new hydrogen bonding between water and the hydrogen. So that's why there is no limit of miscibility between the alcohol and water. They are highly miscible with each other. No limit is there. So melting point, boiling point of these compounds relatively very high due to the strong hydrogen bonding and highly polar in nature as compared to the alkanes. They have very high melting point, boiling point. In alcohol, carbon oxygen are bonded with the sp3 hybridization by the overlapping of oxygen carbon. The alcohol functional group consists of oxygen atom bonded with the carbon with a sigma bond. Both carbon monocarbon oxygen bond and oxygen hydrogen bond are polar due to the high electronegativity. Now there is after physical property structure, then acidity. This hydrogen bonding in structure. Acidity of the alcohols. So due to the electronegativity of oxygen atom, alcohols are slightly acidic. Due to the electronegativity of the oxygen atom, alcohols are slightly acidic. The anion derived by the deprotonation of alcohol is called alkoxide. Alkoxide. You have this alcohol. This is a alcohol, and there is a sodium metal. So sodium metal reacts with alcohol to form a sodium alkoxide. This is the alkoxide, and releasing hydrogen gas. So when hydrogen is removed from the alcohol, this is called alkoxide. And same reaction with water, he is comparing the reaction with water with the alcohol. So this is the more exothermic process, because sodium is very reactive in nature to form a sodium hydroxide. And releasing hydrogen, highly exothermic chemical reaction is this. So this is the water, and hydrogen is removed, you will get hydroxide, and hydrogen is removed, you will get alkoxide. So alcohols react with sodium to form water to give alkoxide. So that's why he said that the negative oxygen present in alcohol shows slightly acidic in nature. After the acidic nature of the alcohols, then preparations of alcohols. Methods for the preparation of the alcohols. So first method is given here, hydration of alkenes. Hydration of alkenes. Hydration of alkene is carried out in the following steps. Preparation of alkyl hydrogen sulfate. First step, hydrolysis of alkyl hydrogen sulfate. So dear students, we have the alkene here, ethene. The ethene plus sulfuric acid. So ethylene hydrogen sulfate. Like this one. So in the first step, only the hydrogen is going to be attached with the carbon. Double bond is going to be removed here. So you will get CH3, double bond is removed, CH2, SO4H. This is the ethylene hydrogen sulfate. Ethylene hydrogen sulfate is a intermediate product, and then there is a hydrolysis. This ethylene hydrogen sulfate hydrolysis about 100 degree Celsius, partial positive charge and partial negative charge is here. So this hydrogen and SO4H, they make the sulfuric acid again, and this nucleophile is going to be attached here to make alcohol. This ethanol is going to be formed. and sulfuric acid is going to be prepared in the two steps. So on the dilution with water, I told you have to put water here and 100 degrees centigrade. Then you will get alcohol and sulfuric acid. This is the first method. Then second method is hydrolysis of alkyl halides. Alkyl halides can be converted into alcohols by using aqueous solution of sodium or potassium hydroxides. So if you have ethyl iodide plus sodium hydroxide, so you will get ethyl alcohol and sodium iodide. So this is the hydrolysis of alkyl halides in presence of sodium hydroxide and potassium hydroxide. Dear students, this is again repetition. I am not going to repeat again this. In the previous lecture, in the previous chapter, we done the organometallic compounds, and these organometallic compounds are Grignard reagents, alkyl magnesium halide or lithium halides. So we prepare the primary alcohol, secondary alcohol and tertiary alcohols. In the previous lecture, if you see that formaldehyde give the primary alcohol, acetaldehyde, and the alkyl group attached with the aldehyde, then you will get a secondary alcohol, and ketones give the tertiary alcohols. So this is I am not going to repeat again this. We done in the previous sections. Then reduction of aldehydes and ketones. Number 4 is a reduction of aldehydes and ketones. Reduction of aldehydes and ketones. Reduction of aldehydes and ketones. So if you see the page number 195, the reaction of aldehyde, ketones and carboxylic acids ester in the presence of nickel, palladium, platinum gives alcohols. So there is a propanol aldehyde. If you see propanol, so hydrogen, platinum catalyst. We want to prepare the alcohol, CH3, CH2, one hydrogen is added here, CH3, CH2, and there is a one hydrogen to make a CH2OH like this one. So if you add one hydrogen here, it will become a CH2, and other hydrogen added with oxygen to make alcohol. So this is the N-propanol. One propanol or N-propanol from the propanol aldehyde by the hydrogenation. The other also method may be. So ketone, CH3, CH2. This is the 2-butanol ketone, and the same conditions, hydrogen, platinum or palladium catalyst. So this is CH3, this is CH3. Okay, now here the hydrogen will be attached from here. One hydrogen come here to make a CH, and other hydrogen bond is going to be vanish double bond to single bond OH. So you will get 2-butanol. So this is the secondary alcohol and this is the primary alcohol. So aldehydes give primary alcohols and ketones give secondary alcohols by the addition of hydrogen in the presence of suitable catalyst is called reduction. So this is the reduction of the aldehydes and ketones to give alcohols. So this is the method number, and there is the another one. Carboxylic acid. Carboxylic acid is not going to be reduced by the hydrogen directly. It is not going to be reduced directly. It is reduced by the very powerful reducing agent, boron lithium hydride or aluminum lithium hydride, or we can use two reducing agents. So one reducing agent is less powerful and more as a highly powerful reducing agent. So that's why you can use lithium aluminum hydride, and other one is called lithium borohydride, which is a weak reducing agent as compared to this. So this hydride will produce the hydride ion, which is going to be reduce the carboxylic acid and changes into alcohols. So this is the lithium aluminum hydride is going to be react with here. So this is a CH3 and this is C. It becomes a CH2 and there is a OH, and also you will get the alcohol functional group here. So this is a CH3, CH2 and OH plus maybe water is going to be formed like this one. So how many hydrides are going to be produced by the lithium aluminum hydride? There are 3. So one hydrogen is going to be attached here to make a CH2, and other is going to be attached here to make a hydroxyl group. So that's why the alcohol is going to be produced by using the lithium aluminum hydride. So according to the conditions, sometimes this reducing agent provides the 4 hydride ions. Hydride is negative charge. Sometimes this reagent gives all 4 hydrogen ions. Sometimes it gives 2 according to the requirement of the chemical reaction. So here I think 4 all are utilized. This is CH3 and the 2 hydrogen are CH2 and this OH and 2 hydrogen make the water here. So this is the reducing agent we use for the preparation of alcohols by using the lithium aluminum hydride complex. Then the reaction of the alkyl magnesium halide with esters. This you done in the previous year. If you go back to the number 17, reaction with alkyl magnesium halide with an ester. There are steps, page number 181. Page number 181. So if you go review this topic again, so this ethyl-methyl ester react with the methyl magnesium bromide, you will get the intermediate tetrahedral complex. Then there is a hydrolysis with it. You will get intermediate ketone here. Then again alkyl magnesium halide reacts with the ketone because ketones are more reactive than esters. then it is going to be changed into tertiary alcohols. So tertiary alcohol is going to be formed in this case. Now reduction of carboxylic acid and esters, the same. This is the same reaction which is given here. This is the same already I have written here by using the carboxylic acid. Carboxylic acid is going to be reduced by using the lithium aluminum hydride. Already I have mentioned this one. The second one is the ester. This is the methyl group, and this one is a propanoate. If there is a hydrogen here instead of methyl, we call propanoic acid. If I remove the hydrogen, this is called a propanoate, and methyl, so we call methyl propanoate or methyl ester. Methyl ester. Or there are two names here. So this is an ester. So in the presence of the very powerful reducing agent, lithium aluminum hydride. So lithium aluminum hydride give the in presence of acid. So it gives the four hydride ions to make the alcohol. So CH3, CH2, CH2, and there is a OH. So this is CH2 SEM, this is CH2 SEM, and this is going to be, the two hydrogen are going to be attached from here to make a CH2, and one hydrogen to make a OH to give a propanol, and there is a CH3, and one there is a remaining of hydrogen to make a methanol there. So you will get the two kinds of alcohol there. So this is the CH3, same, CH2, same. This is the carbon. This carbon is has only one oxygen and oxygen. It produces four hydrogen atoms. So two hydrogen atoms attach to make a CH2 this one, and one hydrogen to make a OH to make a N-propanol, and one hydrogen atom is remain behind to make a methanol. So this is the N-propanol. So N-propanol is going to be formed here. Now, dear students, we complete the methods for the preparation of alcohols, reactivity. Then there is a reactivity of alcohols, very important chemical reactions, very important that I will explain in the next lecture, inshallah. So in the alcohols there are two kinds of bond. There are two kinds of the bond. One bond is between carbon and oxygen. Another bond is between oxygen and hydrogen. So we will discuss in the next lecture, inshallah, carbon-oxygen bond and oxygen and hydrogen bond in the alcohol, and they give different types of the reactions. Inshallah, next lecture we will discuss in this case.